In this presentation, we're going to talk about how to organize raw data. Well, a raw data is when the data is collected but has not been processed for any meaningful use. It is sometimes referred to as source data. A frequency distribution table is one way that we can organize the raw data in order to use it later on for maybe drawing pictures or obtain any other information from it. The distribution table consists of rows that divides the raw data into classes and columns that holds specific information for each class. The question is, how do we determine the number of classes? The number of classes first must be a whole number, and it depends on a sample size of the raw data. It usually ranges from 5 to 20. Maybe it's given in the problem, or we can find the number k, the number of classes, such that 2 to the k is greater than n, the sample size. So for example, if we have a sample size of 30, then we want to get k to be equal to 5 because 2 to the 5th power is equal to 32, which is greater than 30, the sample size. But for most part, you will be given the number of classes that we wish to have for the frequency distribution table. Any frequency distribution table consists of the following columns: class limits, class boundaries, class midpoints, class frequencies, cumulative frequencies, relative frequencies, and percentage frequencies. And each column is going to help us to draw different conclusion for different class and use it to maybe, draw some statistical graphs. If we put all of these together, a frequency distribution table will look like this, where each row represents classes and each column represents specific information about those classes. It is highly recommended that we take the raw data and sort them in ascending order before we start building the frequency distribution table. So let's say we have this sample of 40 exam scores, which obviously is not sorted. So we're going to go ahead and sort this. So from the sorted data, it is very clear that the minimum value is 53 and the maximum value in this case is 100. In order to make the frequency distribution table, first we need to know the class width. And in order to find the class width, we find the range, which is max minus min, and then we take the range and divide it by the number of classes. If that division is a whole number, we add 1, and that's your class width. But if the range divided by the number of classes is decimal, we go ahead and round up to a next whole number. So in our example, the minimum value was 53, the maximum value was 100, the range is max minus min, which is 47. And if we wish to have 5 classes, then we take the range of 47 divided by the number of classes, 5, which we get 9.4. Since it's decimal, we're going to go ahead and round it up. So the class width for our frequency distribution table that we're about to build is going to be 10. Now we're going to go ahead and work on how to find lower class limits and upper class limits. The lower class limits is usually the minimum data value or a convenient value that will be given in the problem. In order to find the next lower class limits, we basically add the class width. And if I want to get to the next one, we add the class width, and so on. So in our example, we're going to start with 53. That was the lowest one. We add 10 to get 63, then we add 10 to get 73, then we get 83 and 93. And these are going to be our lower class limits. Now we also need to find upper class limits. To find the first upper class limits, we take the first lower class limit plus the class width minus 0.1 to the d power, when d represents the number of decimal places in the raw data. In our example, there was no decimal places, so d in that case would be 0. We'll talk about that in more details in just a minute. And then the second upper class limit would be the first upper class limit plus the class width. And then we add it again to get to the third one. Then we add the class width again to get to the fourth one, and so on. So for our example, d was equal to 0. We had no decimal places. So our first upper class limit would be 53 plus 10 minus 0.1 to the 0 power. So once we do this, we're going to get 62. And then for the next one, we add 10, the class width. Then again, add 10 to get 82, add 10 to get 92, and so on and so forth. So our upper class limits for our examples are 62, 72, 82, 92, and 102. Now, I need to mention that it is extremely important that we make sure that our calculation in the beginning is correct, because if we make a mistake now, it's going to affect the rest of the process of building a frequency distribution table. So in the column that we say class limits, then we have 53 to 62, that's one class, 63 to 72, that's the next class, and so on and so forth. Now let's work on class boundaries. The first upper class boundary will be the first upper class limit plus the second lower class limit divided by 2. And then we subtract the class width from it to get the first lower class boundary. And after that, we keep adding the class width to get the successive class boundaries. So our first upper class limit was 62. Our second lower class limit was 63. Their sum divided by 2 is 62.5. That would be the first upper class boundary. To get the first lower class boundary, we subtract 10, the class width, from that. So since we have the lower class boundary 52.5 and upper class boundary of 62.5, now we can keep adding class width of 10 to get a complete list of the class boundaries for our example. So let's update our frequency distribution table. Now we need to find the class midpoints. You take the lower class limit and the upper class limit, add them together, divided by 2. Once you calculate that, that would be the first class midpoint. And then after that, we keep adding class width to get the next class midpoint. So our first one, we take 53 plus 62 divided by 2, that would be 57.5. Now we keep adding 10, the class width, in order to get the next class midpoint for each class. So this is how our frequency distribution look like so far. Now let's look at the class frequency. Class frequency is basically the tally of the data for each class to see how many of the raw data fall within each class. So we can refer to this as F1 frequency for class 1, F2 frequency for second class, F3 frequency for a third class, and so on and so forth. So for our example, based on the sorted data, there were 14 data elements that belong to the first class, 12 that belong to the second class, and so on and so forth for each class. So our frequency distribution table now looks like this. So now we need to find cumulative frequency. Cumulative frequency, we start with the first class frequency that becomes the first cumulative frequency. And then we keep adding the frequency of each class in order to get to the next cumulative frequency. So add F2 to F1 to get the cumulative frequency for the second class. Add F1, F2, F3 together to get the third frequency, cumulative frequency, and so on and so forth. So for our example, we start with 14. That would be the first cumulative frequency for the first class. Then we add the frequency of the second class to 14 to get 26. Then we add 7, then we add 3, then we add 4, and so on and so forth. So this is how our cumulative frequency look like. The relative frequency will be taking the frequency and convert it into a relative frequency. And we're going to keep 3 decimal places for our calculation. So in order to find the relative frequency, we take the frequency of each class divided by the total sample size. So frequency of the first class divided by 40, the total sample size. Frequency of the second class divided by 40 for the second class relative frequency. Take the frequency of the third class divided by 40, which is going to be the relative frequency for a third class, and so on and so forth. And we're going to keep and round our answers into 3 decimal places. Now, if we do everything correctly, then the sum of the all relative frequencies should be equal to 1. So this is how our relative frequencies look like. So again, for the first relative frequency, we took the frequency 40 divided by, frequency 14 divided by 40. The second relative frequency, we took 12, the frequency of the second class, divided by 40. The third one, 7 divided by 40. The fourth one, 3 divided by 40, and so on and so forth. Now the percentage frequency is very easy. We're going to take the relative frequency and multiply it by 100, basically we're moving the decimal point to the right twice to write it in percentage frequency. So you take the relative frequency of the first class times 100. Take the relative frequency of the second class times 100, and so on and so forth. So 0.350 times 100 would be 35.0, but don't forget this is a percentage frequency, so you have to place a percent sign at the end. So you take the relative frequency of the second class times 100. Take the relative frequency of the third class times 100, and so on and so forth. So we're going to keep the percentage frequency to 1 decimal place. So our percentage frequency is completed, and our frequency distribution table is also completed. Now in our next presentation, we will use this frequency distribution table to do some statistical graphings. I hope this presentation helped you guys understand how to build a frequency distribution table.